Hi, good evening and good morning, everyone. I'm Sunny Barnett and I'm going to be your moderator for today's webinar. The webinar will run for about an hour and a half, and we're going to give you time at the end to ask lots of questions. We have a lot of content to go through and very interesting content as well. So what I suggest that you do is, if you have any windows open or applications open at the moment, you're better off to just close those down, because the quality of the broadcast will be much better if you do that to start off with. Also, if you're familiar with webinars, you can see that you actually have a question box. Now, if you're not familiar with webinars and you can't see where that question box is, you've got a red arrow that's pointing to the left. If you click on that red arrow, it will open up a control panel that will actually allow you to see where you can type in your questions. So it would be really great for us for you to type in your questions, and we will address as many of those as we can at the end of this presentation. So just as a start for me, I want to make sure that people can hear me. So if you could click on your hand button to indicate that you can hear me properly, please. Excellent, thank you. Thank you for putting up your hands. Okay, excellent. Thank you, appreciate that. All right, so let's actually start with this webinar today. So welcome everyone, and thank you very much for joining me from the US and from Australia today. And this is our first in this SNP presentation series. We are certainly very excited to be sharing our knowledge with you. As many of you will know, this is the fruition of many, many hours of research and clinical insights, so we hope that you enjoy it. It's probably fair to say that when it comes to genes and what we should and shouldn't be doing, there is a lot of conflicting messages out there. You will hear many people say, don't treat the SNP, treat the person. Well, we think that's obvious. But if you keep doing what you've always done, there will always be patients that don't get better. But what we are saying is that when you have the insights of someone's genetic data, it really gives the practitioner a roadmap of what they may be dealing with. The analogy of the freeway seems to be one that many people are using at the moment, so let's go with that. Just imagine if you are driving down a freeway and there are lots of potholes in your lane, but in the lane beside you there is only the occasional one. Your side of the laneway is closer to the mountain, so has had the influence of the environment and rain running over it, which has caused the potholes. You also have an old beat-up car that you don't really look after very much. So it's not hard to imagine that when you drive down the freeway, you and your car are going to be more susceptible to these potholes and potentially will have more damage and may even crash. Well, that's what we are endeavouring to show you in this series, that people's environment and lifestyle influence the genes. Their parents influence their genes, as do their parents. If you can take a full case history and look at the genes, you can gauge where someone's susceptibility lies. It gives you a roadmap on which critical paths you should follow. We are dealing with complex biochemistry here, no more, no less. If you can fix the biochemical imbalance, then patients will and do get better. So what can you expect to gain from this series? The most important thing is to understand the key significance of the genes in the variant report and know that they don't work in isolation, but with groups of genes. We will endeavour to give you the most up-to-date research that we can. But remember, these are ever-changing and every day new research comes to hand. You are so fortunate to have the research skills of Sterling Hill and the clinical insights of our practitioners, Carolyn Adelsky and Cynthia Smith. This will help you in determining what questions you should be asking your patients, what nutrients help slow down or speed up an enzyme, and most importantly, where you start. The format for today's presentation will be as follows. Sterling Hill will give us her insight into the research in each category. Cynthia Smith will then run you through the key biochemistry of each SNP grouping, and Carolyn Adelsky will take you through the specific research for the SNPs and clinical insights. So without further ado, I'd like to introduce you to our speakers. So our first speaker today is Sterling Hill. Now, Sterling was a highly successful businesswoman for many years until 8 years ago when she became ill with clotting issues. She went from physician to physician, but her condition progressively deteriorated. She lost everything. As traditional medical thinking was failing, she reached out to alternative medicine community and the work of Amy Yasko, PhD, and Dr. Ben Lynch, and discovered the world of epigenetics. She learned the basis of her clotting issues resided in the methylation cycle. After regaining her life from treatment, Sterling realized that the medical and lay community knew little of epigenetics and nutrigenomics. She realized that these subjects were of vast importance to the health of everyone on the planet, often being the proverbial stone that was left unturned in chronic illness of any type. As a result, Sterling started MTHFRsupport.com to learn and share the knowledge of genetic polymorphisms and their effect on health. Her passion is to educate the world of the true root cause of chronic diseases and link expert healthcare providers with those in need. From her adversity, Sterling Hill has become one of the greatest patient advocates of our time, consistently counselling patients about their SNPs and teaching healthcare providers the importance and methods of nutrigenomics. So I'd like for Sterling to just say hi to everyone. Hi Sterling, if you'd like to unmute yourself and say hello to everybody.
Oh, hello everyone.
Fantastic. Thank you for being here, Sterling.
You're welcome.
Our next speaker today is Carolyn Nadowski. Carolyn Nadowski is the founder of MTHFR Support Australia. She is a MD, herbalist and nutritionist who has a Bachelor of Herbal Medicine, Bachelor of Naturopathy, Advanced Diploma of Naturopathy, and Diploma of Nutrition, also having studied courses in genetics at Duke University and the University of Maryland in the US. Carolyn became interested in methylation health issues when she noticed that some of her patients were not just getting better, despite known and trusted protocols. She began to delve more into the MTHFR gene and discovered that by addressing methylation and genetic polymorphisms, her patients started to improve. Some reacted very quickly, and those who had chronic disease for many decades started to improve where they never had before. She now uses genetics and nutrigenomics as the basis of her approach to better health. Carolyn's knowledge of the biochemical pathways in the methylation cycle is unique, and this is what gives her the edge in addressing chronic health conditions. Carolyn is a regular speaker at MTHFR events and provides both patient and practitioner training through her many webinars and presentations and online learning environments. So Carolyn, would you like to say hello to everyone?
Hi everyone, great to be here today.
Thank you. Now our third speaker today is Cynthia Smith. Cynthia has developed a passion for functional medicine, clinical nutrition, and genetics nutrigenomics. Her desire to assist individuals with complex conditions that have been recalcitrant to traditional forms of therapy. She utilizes nutrition, genetics, and a comprehensive health history. She is also familiar with interpreting medical testing, Genova diagnostic testing, neurosciences testing, Cyrex testing, immune system testing, and many others. She also has a wide breadth of knowledge of supplements, herbs, glandulars, and the various companies who make and sell them. So Cynthia, if you would like to say hello. Hi Cynthia, can you hear me?
Yes.
If you'd like to say hello.
Hello, everyone.
Hi there. So our first presenter today is Cynthia, so I'm going to hand over to you now.
Thank you. Okay, so I think what we're going to do is we're going to start at a high level and then give overviews, and then we're going to drill down kind of snip by snip. Somewhere near the beginning, I think Sterling's going to talk about all of the SNPs at a high level, and then, like I said, we'll go down. We'll start to go deeper as we go along. So what I want to first start with is kind of the overview. So today we're going to talk about phase 1 liver detox enzymes, which are primarily these cytochrome P450s. Following that, next week we're going to begin talking about phase 2. Now they interrelate, so I might talk about phase 2 a little bit while we're going through phase 1, just to give the overview. But like I said, we're going to drill down as we go. So the liver can be looked at as being broken down into 2 phases. The first phase are the cytochrome P450s, and their job is to take lipid-soluble molecules like cholesterol, steroid hormones, and other lipids, including some of the xenobiotics and some of the chemicals that we encounter in our daily life, and break them down into a more soluble form. Now, they're not water soluble, but they're broken down. It's the beginning of the breakdown to make them water soluble. Phase 2 picks up the intermediary metabolite and finally completes the process of making the molecule water soluble. So phase 1 is the start of the process. Now if we look at the next slide, we see a picture of a liver, and you can see here that the phase 1 cytochrome P450 enzymes do a number of reactions depending on the molecule that comes in. Here it's labeled a toxin. The chemical process could be oxidation, reduction, hydrolysis, hydration, and dehalogenation. Now, in order for these CYPs to do their job, they also require these nutrient cofactors. So you'll see a list there of various vitamins. Glutathione is a big one, and phospholipids. The other thing is that these particular enzymes are heme dependent, meaning that they're dependent on iron. So we have to have that heme molecule being pretty robust for these to work well. Now, when a toxin comes in and goes through phase 1 detox, oftentimes the intermediary metabolite is more toxic than the original molecule. And we see this oftentimes when it comes to hormones like estrogen. So it's very important that our phase 1, the intermediary metabolites coming off of phase 1 are quickly picked up and conjugated by phase 2 and what I call neutralized and made water soluble. From there, they're taken out either through the urine or through the bile, and eventually they're excreted. Now, some of these molecules that come out of liver detox, these excretory derivatives, oftentimes, especially the estrogens, will sit in the digestive tract, namely the colon, and they can be brought back to intermediary metabolites by certain chemicals. Beta-glucuronidase is one, and that's something that's made by bad gut bacteria. So just because the toxin makes its way through, phase 1 and phase 2 doesn't mean you're home safe, because like I said, they can be further metabolized in the colon and lose their neutralization and be dropped back into intermediary metabolites. The other thing that can happen is these intermediary metabolites can escape from the liver and wreak some havoc. So it's really important, and we're going to discuss this, that phase 1 speed and phase 2 speeds are matched so that you're not rushing through phase 1 and then limping along through phase 2. Now the next slide is the same picture, but I've put in the different cytochrome P450s, and you can see the list. I didn't have enough room to get them all in, but you can see that these are all phase 1, and then you can see in phase 2 we've got the different categories of acetylation, glucuronidation, glutathione conjugation, peptide conjugation, sulfation, and then the really big one is methylation, and I think that's going to be a whole class unto itself. So this week we're going to go through the CYPs. Next week we're going to go through all of phase 2 with the exception of methylation. We're going to save that for its own class. Now the next slide is just another version of this. I do want to mention a couple things about phase 1. As we go through these slides, you'll see that certain SNPs are upregulations, meaning that that particular CYP enzyme is working faster than normal if there's a SNP in it, or that it's working more slowly. There's instances where if you have a SNP it can be aggravated to upregulate depending on your environment and your lifestyle, what you're exposed to. Now, one thing I want to mention about these CYPs is they're affected by glyphosates, which are Roundup, and we're starting to see the effects of this. I just want to kind of go off on a little side note here. Roundup became used in the 1990s, and the amount of Roundup that's being sprayed on our grains, specifically corn, wheat, alfalfa, soy, has entered our food chain and is now accumulating not only in the grains that we eat, but also in the animals that eat those grains, and we're starting to see the effects. There's a Dr. SNP who's done a lot of research in this area, and if you read her work, what you'll see is that this Roundup doesn't affect our cells directly, but it affects our gut bacteria cells. So Roundup is an herbicide, and it kind of kills the weeds by attacking their a metabolic pathway called the shikimite pathway. Now, we don't have that pathway, but our gut bacteria do. And as we go along in this series, you'll see the importance of a good gut microbiome and good gut bacteria. And if we don't have that, then we start to see effects on our immune system. You'll see a lot of autoimmune and also effects on neurotransmitters. So that's something to keep in mind with this phase 1 as we talk about it. Now, here again, the slides talk about the different nutrients that are required. I know milk thistle is very popular as a liver detox, but you can see some other things here. So let's go in and look at some of these SNPs in depth. Sterling?
Hello? I thought we were going to play, or do you want me to recite these? Or do my play? Hello? Anyone hear me?
Hi, Sterling, just one moment, please. Carolyn, can you hear me? You need to unmute yourself.
Yes.
Carolyn, the audio hasn't played, so we need to get Sterling to do her presentation.
Okay.
Okay.
Hi,
Sterling.
Just give me a second.
Okay.
I thought I could not play. All right, you guys just have to give me a second. So I just want to go through the snippets in the right order. So the snips. Just give me a second. We had it recorded for you, so I wouldn't take up a lot of time. And I guess the audio is not working, guys. Just bear with me, and I just want to get them in order for you guys, so you guys don't lose your place. So I'm trying to pull up my order here. All right. I'm almost there, guys. All right. I guess we will start with CYP 1A1. How about that? Okay. CYP 1A1 is cytochrome P450 family 1, subfamily A, polypeptide 1. And the enzymes are coupled to glutathione to catalyze bioactivation and detoxification of mutagenic or carcinogenic compounds. CYP1A1-2C polymorphism increases risks of certain cancers like leukemia, lung cancer, endometrial cancer, prostate, colorectal, esophageal, and oral. Also, a smoker or someone who consumes charred meat regularly, like when you put it on the grill, kind of charcoal it, burn it.
Muted.
People are exposed to xenobiotic, and those people exposed to xenobiotics from the environment have the potential to convert these hazardous compounds to even more carcinogenic substances. And CYP1A1 is involved in an NADPH-dependent electron transport pathway. It oxidizes compounds including steroids, fatty acids, and xenobiotics. Before I go on with the other CYPs, all the CYP450s are involved in an NADPH electron transport pathway, so keep that in mind. Things that you should be concerned about with CYP1B1 would be if your estrogen or intermediate metabolites are elevated. You may want to consider avoiding estrogen-mimicking foods and chemicals, genetically modified foods, conventional foods, sprayed with glyphosate. Foods and chemicals that may elevate or mimic estrogen are coffee, black tea, chocolate, soy, dairy, or meat from animals injected with growth hormone, non-organic chicken eggs containing growth hormone, BPA, flaxseed, yucca root, carbonated beverages containing caffeine, dried apricots, dried prunes, dried dates, sesame seeds, chickpeas, beans, peas, alfalfa sprouts, bran cereal, and tofu. All right, now on to CYP1A2. It is also called CYP450 family 1, subfamily A, polypeptide 2. CYP1A2 is involved in an NADPH-dependent electron transport pathway. It oxidizes compounds including steroids, fatty acids, and xenobiotics. Because the CYP1A2 gene is one of the key enzymes that metabolizes estrogen, some polymorphisms have been linked to hormone-related cancers. CYP1A2 functions in xenobiotic metabolism, including the inactivation of therapeutic agents such as caffeine, theophylline, phenacetin, and warfarin. As a result of CYP1A2 is compromised due to, for example, high caffeine consumption, then an individual may potentially elevate estrogen levels. If you have evidence from hormone testing that your estrogen or estrogen intermediate metabolites are elevated, again, you may want to consider avoiding estrogen mimicking foods or chemicals, genetically modified foods, conventional foods sprayed with glyphosate. Now, we kind of went over some of the foods and chemicals to avoid, but I'd like to just add in things that contain BPA, cash register receipts. BPA is used to line canned goods, canned sodas, including healthy bubble water, plastics such as storage containers, milk jugs, and water bottles. Also, plastic lids used for to-go coffee cups. Don't drink coffee through the plastic lid. There's typically a small triangle at the bottom of the plastic bottles that include a number. These numbers, 1, 2, and 5 at the bottom of the plastic bottles are BPA-free. Organic meat from grass-fed animals, bovine growth hormone-free, antibiotic-free are better choices for individuals with CYP1A2s and elevated estrogen levels. CYP1B1, cytochrome P450, family 1, subfamily B, polypeptide 1. CYP1B1 L432V is one of the major enzymes involved in the hydroxylation of estrogens, a reaction likely to be relevant in hormonal carcinogenesis. Preferentially, it oxidizes 17-beta estradiol to the carcinogenic 4-hydroxy derivative and a variety of paracarcinogenic compounds. CYP1B1 is involved in an NADPH-dependent electron transport pathway. CYP1B1 oxidizes the 17-beta estradiol into the carcinogenic 4-hydroxy derivative and a variety of procarcinogenic compounds to their activated forms, including polycyclic aromatic hydrocarbons. The CYP1B1 enzyme is active in many tissues, including structures of the eye. More than 140 CYP1B1 gene mutations have been identified to cause early onset glaucoma. A lack of the CYP1B1 enzyme likely disrupts normal development of the eye. CYP1A2, cytochrome P450, family 2, subfamily A, polypeptide 6. CYP2A6 is involved in the metabolism of xenobiotics in the body. CYP2A6 is the primary enzyme responsible for the oxidation of nicotine and codeine. CYP2A6 is also involved in the metabolism of several pharmaceuticals, carcinogens, and a number of coumarin-type alkaloids. In the book the compendium we've gotten out, you can look at a lot of the CYP SNPs and you'll see the substrates, inhibitors, and inducers. Again, CYP2A6 enzyme is involved in metabolizing the nicotine and many other substances. This enzyme is also an NADPH electron transport pathway. Diseases associated with the CYP2B6 are ephedrins. Ephedrins is a central nervous system toxicity. CYP2C9, cytochrome P450, family 2, subfamily C, polypeptide 9. Individuals with the CYP2C92 or CYP2C93 variant may have an increased risk of GI bleeding with the use of specific NSAIDs, nonsteroidal anti-inflammatory drugs. CYP2C91 produces normal enzymatic activity, whereas CYP2C92 produces reduced enzymatic activity. CYP2C9 plays a role in the oxidation of xenobiotic and endogenous compounds. CYP2C19, cytochrome P450, family 2, subfamily C, polypeptide 19. CYP2C1917 encodes an ultra-rapid upregulation of the enzyme, resulting in extensive metabolism of CYP2C19 substrates. So, for example, a person taking an antiplatelet medication may be at increased risk of bleeding. CYP2C1917 also metabolizes xenobiotics, and also proton pump inhibitors and some anti-epileptics. Again, we have a full list in the compendium. CYP2C19-1 produces normal enzymatic activity. CYP2C19-2 produces reduced enzymatic activity. CYP2D6, cytochrome P450, family 2, subfamily D, polypeptide 6. It is responsible for the metabolism of many drugs and environmental chemicals that it oxidizes. It is involved in the metabolism of drugs such as antiarrhythmics, androstenedione antagonists, and tricyclic antidepressants. It metabolizes xenobiotics, herbicides, and insecticides. CYP2D6 is responsible for the metabolism and elimination of approximately 25% of clinically used drugs in a process referred as O-demethylation. 20 to 30% of all drugs are metabolized by CYP2D6. Now, this particular CYP2D6 gene is very, very important. Again, it is they have a huge list of substrates and inhibitors and inducers, and those can be found in the compendium that Cynthia had put together for us all. CYP2D6 1 has normal enzymatic activity. CYP2D6-2 has increased enzymatic activity. CYP2D6-3, CYP2D6-4, and CYP2D6-5 have no enzymatic activity. CYP2D6-9, CYP2D6-10, and CYP2D6-17 have decreased enzymatic activity. CYP2E1, cytochrome P450, family 2, subfamily E, polypeptide 1. It metabolizes drugs like acetaminophen, halothane, and chlorzoxone. CYP2E1 is involved in the metabolism of xenobiotics. CYP3A4, cytochrome P450, family 3, subfamily A, polypeptide 4. CYP3A4 G392A is involved in the androgen metabolism and confers a 10-fold higher risk of aggressive prostate cancer in African American males. 40 to 45% of pharmaceutical drugs are metabolized via this enzyme. It metabolizes xenobiotics, aflatoxin, and food mutagens. CYP3A4 oxidizes xenobiotics such as toxins and drugs. The expression of CYP3A4 has been linked to estrogen-related cancers. Caffeine can elevate estrogen levels up to 70% if CYP3A4 SNPs are present. So again, in the compendium we have the lists are rather large. We do have lists of substrates, inhibitors, and inducers. CYP3A5, cytochrome P450, family 3, subfamily A, polypeptide 5. In liver microsomes, CYP3A5 is involved in an NADPH-dependent electron transport pathway. It oxidizes a variety of structurally unrelated compounds, including steroid hormones, fatty acids, and xenobiotics. It metabolizes many drugs and steroid hormones like testosterone and progesterone. CYP4A11, cytochrome P450, family 4, subfamily A, polypeptide 11. CYP4A11 localizes to the endoplasmic reticulum and hydroxylates medium-chain fatty acids such as laurate and myristate, and is involved in drug metabolism and synthesis of cholesterol, steroids, and other lipids. It catalyzes the omega and omega-1 hydroxylation of various fatty acids such as laurate, myristate, and palmitate. Okay. Just give me a second, guys. Sorry. Okay, yeah, okay. The following test, wait, hold on one second. I'm just, I'm a little lost here. I have my pages wrong. Okay. All right, I think I'm going to HFE now. Just give me a second. I'm off the CYPs. Let me get my HFE together. All right, this one's really an important SNP for liver, for detoxifying iron out of the liver, metabolizing it. All right, HFE is also called the human hemochromatosis protein. HFE is responsible for regulating the absorption of iron. The iron storage disorder hereditary hemochromatosis is an autosomal recessive genetic disorder that usually results from defects in this gene. Hereditary hemochromatosis, also called HH, is an iron storage disorder where excess iron is not effectively removed from the blood. In serious cases, this excess iron will cause iron overload, and if untreated can lead to cirrhosis of the liver, diabetes, hypermelatotic pigmentation of the skin, heart disease, liver cancer, depression, fatigue, and other problems. Now, this part's really important to know. HFE is related to positive regulation of T-cell mediated cytotoxicity. Again, we do notice that a lot of chronically ill people with elevated ferritin also will test positive for Lyme. So that's a big note to put down. Those with 2 copies of hereditary hemochromatosis alleles very likely have some trouble processing iron, but won't necessarily have hemochromatosis. Hemochromatosis is only diagnosed when blood iron levels exceed certain thresholds. If low ferritin, then you could have an oxalate issue. If you see multiple HFE SNPs, and then you see low ferritin, there could be an oxalate issue there because oxalates do bind to iron. The following tests can be used to detect an overload of iron in the body: serum ferritin, serum iron, total iron binding capacity, serum transferrin saturation. Now, if any of these are out of range, additional testing may be suggested by your practitioners, such as liver function tests, Lyme disease, alpha beta protein levels, CT scan, MRI of the liver, blood sugar levels, SIBO, small intestinal bacterial overgrowth, electrocardiogram, and ultrasound. Okay. Possible treatments include phlebotomy, calcium supplementation. Some practitioners will suggest a high oxalate diet, but as we're learning now, oxalates, you don't really want them getting too high because they share the same transporters as sulfation. And glutathione, of course, is a sulfur-based molecule, so you could cause another problem. So in my opinion, that would not be a wise idea to do. Now, consuming tea or coffee with the chemical tannin is also a possible treatment if there's not problems and they can consume coffee and tea without other problems occurring. Unlike other alcohol, red wine also contains tannins. Tannins are not recommended if there's liver damage either. Iron mismanagement resulting in overload can accelerate neurodegenerative diseases, sorry, tongue-tied there, such as Alzheimer's, early onset Parkinson's, Huntington's, epilepsy, and multiple sclerosis. On that note, with multiple sclerosis, they're doing a certain procedure on some people with multiple sclerosis called CCSVI, and they're finding that in their arteries leading to the brain, like the vertebral artery, that there is iron buildup. And sometimes when they put stents in, some people go into remission from MS. So there's a huge, huge connection between elevated ferritin and multiple sclerosis, which is Lyme, which is connected to also elevated ferritin. Also, G6PD is a gene that is really important to look at as well when you're seeing HFE SNPs, because people with G6PD have iron storage issues as well. Another gene that you won't see on people who have the V2 chip, but people who did their 23andMe before November of 2013 got some additional SNPs tested before they switched to the other chip, and one was RAB6B. That, along with HFE, G6PD, and then also SAD2, can all cause elevated ferritin. PON1, peroxidase 1 protein. Polymorphisms in this gene are a risk factor in coronary artery disease. PON1 hydrolyzes the toxic metabolites of a variety of organophosphorus insecticides and nerve gases. These people really have a big, big problem with insecticides and nerve gases. It's huge. For example, people that came home from Vietnam and that developed Agent Orange, most of them had PON1 mutations. The expression of PON1 is developmentally regulated. Newborns have a very, very low levels of PON1. PON1 is important in the prevention of vascular diseases. Sporadic amyotrophic lateral sclerosis, SALS, causes progressive muscle weakness because of the loss of motor neurons. SALS has been associated with exposure to environmental toxins, including pesticides and chemical warfare agents, many of which are organophosphates. And this is linked to PON1 gene. RAB6B is relevant to hemochromatosis as it is associated with the serum transferrin levels. It is also called RAS-related protein RAB6B. The risk allele appears to be C with the RAB6B SNP we have in the report. RAS-related protein has a role in retrograde membrane traffic at the level of the Golgi complex and may function in retrograde transport in neuronal cells. Okay, all right, guys, I'm trying to get to SOD3. I am so sorry about this. I'm just going to pull it up a second because I don't see my page there. I will be more prepared next time. Sorry, I didn't know my recording was going to knock out on us. I've got SOD3 to talk about, and I can hand it over. Give me a second. Sorry. All right. I'm almost there, guys. Just give me a second. I just want to make sure I get every bit of information out to you. So I just pulled up my note. I lost that note. All right. SOD3 protects the extracellular space from toxic effect of reactive oxygen intermediates by converting superoxide radicals into hydrogen peroxide and oxygen. It's also called superoxide dismutase 3. That's what SOD3 is called. This protein has several cofactor binding sites. It binds one copper ion per subunit, and it binds one zinc ion per subunit. It is also heparin binding. The product of this SOD3 is thought to protect the brain, lungs, and other tissues from oxidative stress. Diseases related to SOD3 are coronary artery disease, pulmonary emphysema, prostate cancer. SOD3 plays a role in therapeutic effects of tissue damage recovery. Foods rich in superoxide dismutase are sprouts and algae. Okay, I think I'm done. I think SOD3 was the last one, so Carolyn, Cynthia, you all can take it over. I think Carolyn's next.
Unmuted.
Hi, Cynthia's up next.
Okay, so let's recap a little bit. Sterling went through all the CYPs pretty rapidly. We're gonna drill down a little bit. I want to go back though and explain what a substrate, inhibitor, and inducer is. So for each one of these CYPs, there are things that they grab onto and process. So for example, let me pick an easy one. Okay, let's take CYP2D6. That's one of my favorite ones. CYP2D6 is an enzyme that's very busy breaking down a lot of the medications that we take. That and also CYP3A4. So a substrate means that when that molecule hits the liver, CYP is going to grab it, CYP2A6. And a couple of the substrates for that are Abilify, an antidepressant. Another one is codeine. Now, some of these substrates also, besides being processed through that particular CYP, so for example, 2D6, also slow the enzyme down. And so that would be called an inhibitor. So for example, if somebody's taking codeine for, maybe they've had some oral surgery or something, and then they take an antidepressant, not only are those both being processed through CYP2D6, but the combination is slowing down the CYP2D6 enzymatic activity. So for your own benefit, you might want to go back and look at your cytochrome P450s, look at the substrates and the inhibitors, and see if you're slowing the enzyme down or speeding it up. If you speed the enzyme up, it's called an inducer. So there's lists on the internet. There's lists in our new Compendium 1 book. Everything is is very clearly spelled out in the book. The other thing that Sterling mentioned were oxalates. Now, oxalates are something that, as she said, affects vitamin B6 and they have a far-reaching effect on the body if certain enzymes are not working properly. And oxalates are a class of anti-nutrients that come from plants. So, for example, high oxalate foods might be, kale. And as we go through the presentation, we'll talk about these anti-nutrients and how they can impact these enzymes. But oxalates are a big one because they impact vitamin B6, and as you'll see, vitamin B6 is very important to many of these pathways. So Sterling talked about all of these, the CYPs, which are the classic phase 1 liver detox. She also talked about HFE, PON1, SOD3. Those are associated with phase 1, but they're not considered the classic phase 1 liver detox SNPs. So let's keep going here. Next slide. A lot of this is a recap, but one thing I want to point out is these CYPs are highly impacted by things like PAHs, and as Sterling mentioned, those can come from charbroiled meats. So we have to be careful. That steak on the grill might be yummy, but it's affecting your CYP1 family. I have a note down here. CYP1A2 is a younger gene, and there are a couple dozen drugs that are metabolized by CYP1A2, but the original CYPs back in the millennia ago were the CYP, the 1A1. So let's go to the next slide. Here's another note about barbecued meats, smoking, xenobiotics, and then of course the estrogen mimicking foods, and there are quite a few out there. And I know there's a lot of talk about, why are children developing younger? Why are girls having their menses at 9 now? Some of this has to do with these estrogen mimicking foods that we can find oftentimes, in beef that's been treated with growth hormones and other hormones, and even the antibiotics that they're fed. So that has an impact on these CYP enzymes. As I mentioned before, the cofactor is heme. So anemia will affect CYP function. Iron anemia. And there's a couple notes here about the how many superfamilies there are for these CYPs. But suffice it to say, there's dozens of cytochrome P450 enzymes that are hard at work doing phase 1 liver detoxification. They can be upregulated either by SNPs or by our environment. They can be downregulated by SNPs or our environment. So it's really important that you go back, look at your CYPs, get on Wikipedia or look at our compendium and see how certain things you're doing could be affecting you and your liver. Now, Carolyn's going to start talking about the different RS numbers, and I want to explain one thing. We kind of skipped over it at the beginning, but when you see something like RS 1801272, what does that mean? So I analogize RS as, if you look at your DNA and you untwist the DNA, it looks like a ladder with rungs. And I analogize that RS number to a rung on a ladder. So when we're looking at a particular SNP ID, for example, 1048943, we're looking at a particular rung on that DNA ladder. And on that rung are 2 nucleotides. And when those nucleotides are copied by messenger RNA and carried out of the nucleus, they become part of a sequence of nucleotides that translate into amino acids. As the particular enzyme is being built using our DNA, those nucleotides in their particular sequence, one sequential rung after the other, are used to determine the amino acids that's selected for the enzyme. And depending on that amino acid, if it's the incorrect amino acid, it can affect the enzyme function. And so all of these RS numbers that you see on Sterling's app, that you see us talking about, are rungs on the ladder that have been determined to include nucleotides where it's affected the amino acid and then therefore the enzymatic function. that the enzymatic function can be something where the enzyme isn't quite the right shape, or maybe that particular location is a location for a docking molecule. Let's say zinc is a cofactor. So as we look at this, you'll see that when it says risk allele, that means that if you've got that particular nucleotide and that's translated into the amino acid for the enzyme, it's going to have an impact. So Carolyn, take it away.
Thank you. So yes, I'm going to really delve into the research as much as I can. And I think one of the things that's really important to understand on that note is that you will see risk alleles change, and you will see risk alleles that don't necessarily match the variant report. And it's because some people look at the risk allele in terms of the DNA base change, and some people look at the risk allele that compares the amino acid change that results because of that base change. So that's why it does get confusing. So we've tried to make this as simple as possible, and where there's multiple research that shows us different alleles, I'll put that in. If we don't have the risk allele here, it means that we haven't got the research, but as you know, it's changing daily. So if we look at the research on the CYPs, we can see that these SNPs obviously don't work in isolation, as Sterling has said. And much of the research with the CYPs look at multiple genes. So for example, with the 1A1, we often see it combined in the research with the GSTM1 and the GSTT1 because they work in unison when we're talking about the metabolism of environmental carcinogenic compounds. So it's also very important to remember we're not looking at one gene in isolation. We look at this, and I think this is the value of this class, is that you're going to get to understand some of the combinations of things that are really important to look at. So as Cynthia said, the CYPs, they're coupled to glutathione to detoxify our mutagenic and carcinogenic compounds, like these polycyclic aromatic hydrocarbons, and that's why you will often see it in the research combined with the glutathione SNPs. And these PAHs are carcinogenic compounds. They're present in tobacco, smog, and urban air, and they result from incomplete combustion of fuels like diesel, wood, and gasoline. So it's almost impossible for us to look at a life without them. However, if we see people with this CYP1A1, we certainly have to caution them. CYP1A1 is also involved in the 2-hydroxylation of estrogen. So specifically, it's involved in the conversion of estrone, which is our E1, and estradiol to our 2-hydroxyestradiol. So you can see here that the risk allele for the 1A1/2 is really what the research is showing us, is that it's the GG allele, which is known as the VAL allele, that represents an increased activity. And at times it's almost impossible to work this out, and it can take us a week to find out whether this is an up or a down regulation. So you're getting a lot of information here that is countless hours. The 1A1 number 4, it's really the T allele. And interestingly, it is slowed by resveratrol, and it's slowed by glucosinolates. So one of the most important things with the 1A1 is we've got to make sure that people are not smoking. And the research suggests that with this 1A1 number 2, it probably originated in Latin America and Asian populations. And it's really important for those practitioners in the US that some 35% of the Latin American population have this mutation, homozygous. So, and particularly the Mexican population have a very high susceptibility to the effects of these environmental carcinogens. And so the CC allele is what you're looking at because it's an increased activity. So these environmental carcinogens are not sufficiently broken down, and so they're not adequately metabolized. In the research, you'll see this, as I said, as ILE462 Val allele. And I've put that down there because most of the research puts it as that. The 2C allele also has got links to breast cancer. And I think the key point that we need to remember if we look at breast cancer association with both these alleles is that the C was found to be associated with a significantly higher risk of breast cancer in African American women who smoked and Taiwanese postmenopausal women, but it's associated with a reduced risk in Japanese and Chinese. So what we're saying is that racial differences really have a big impact on a lot of these genes. And this CYP1A1 down the bottom, that final one, 4646903, the women carrying the T allele were found to have a 1.72 times greater risk of developing breast cancer if they were Korean. In this, this is a great study that looked at the frequency of the CYP1A1 allele in the Mexican population compared to the other populations. And you can see that 35% of the population had some combination of the 1A1, the GSTT, and or the GSTM. So we know that they are certainly more susceptible. And the Chinese and Japanese had high frequencies as well. This isn't in your on the variant report, but it is relevant. And there was significant variation in E2 concentrations, again, racially and ethnic-wise, and particularly the Japanese women with a CC genotype had lower E2 concentrations than did Japanese with the AC. So again, different ethnic groups will have a difference in how they metabolize each of these carcinogenic products. In the 1A1, this SNP is primarily studied in relation to cancer susceptibility, and I'd really, if you're interested, it's a really good paper that I've put there for you, and it was published in the Cancer Journal in 2012, and it showed that there was a positive association between the CC allele and cancer, especially in Caucasians, because there's over 200 polymorphisms in the 1A2 gene, but the expression of this gene was definitely associated with a 2 to 3-fold increase in activity in Caucasians. And this study, again, a great one, and the conclusion was that the CYP1A2 762551 is likely to be associated with susceptibility to cancer in Caucasians. And so there's not many studies that looked at in the cancer susceptibility in Caucasians, so very good paper there. The 1A2, it's the C allele, particularly if there's an overload of caffeine because they just can't break it down. And CYP also functions in xenobiotic metabolism. And so potentially this could mean that there's an elevated estrogen by up to 70%, and that's big. So our CC allele is the slow allele. Coffee is protective for them, but it's the AA allele that is the fast metabolizer, so increased activity. And the 1A2, this is a primary isoenzyme responsible for demethylation of caffeine. And so variation in this 1A2 represents quite a major source of how people break this down. You can see that it metabolizes caffeine, it metabolizes xenobiotics like many of the other CYP1A2s. It converts estradiol to 2-hydroxy, and you'll see in some populations that it can be much higher or lower depending on their ethnicity. And I think that's probably all I really wanted to say about that one. So the clinical pearls which from each category we will give you, and it's just something for you to think about when you're seeing particularly homozygous SNPs. And as you all know, you're not going to just look at the SNPs and go, oh, well, you must have a problem. With your full case history that you're doing, if you see CYPs or any of these SNPs that are homozygous, you're going to be thinking, you're going to be laddering as far as the questions are going to say, okay, is a potential problem for this patient? So when you're looking at the CYP1A1s, look at the GSTM, the GSTT, and other glutathione SNPs. Smoking is obviously a big issue, and as is charred meats. Explain where possible the genotoxic effects of these PAHs, like tobacco, smog, and particularly in polluted cities. You're not going to do a lot about that, but surely we can help protect our liver function and give liver support. As Cynthia said, heme is the cofactor of the CYP, so it's really important to look at our iron level, both the ferritin and iron function, and also always coach your patients in avoiding xenoestrogens. I mean, everybody's walking around with plastic water bottles. We've got to really coach our patients that they shouldn't be doing it, and clearly glutathione support is really important. We need to look at foods or chemicals that may elevate or mimic estrogen or bind to estrogen receptors, and there's a whole list of them there. And we'll certainly go into that more when we look at the combination with the COMT and CYP1B1. 1A1, so the changes in the diet, preferably organic meat from grass-fed, no hormones, no antibiotic, and resist the need to barbecue. Being Australian, barbecuing meats is our thing. We probably do it most of the year. So we've got to be really cautious that we're not charring those meats to the point where we're creating these PAHs. Avoid canned foods and soft drinks because of the lining, and we need to look for beverages that are non-BPA containers. As Sterling said, handling cash register receipts are a big issue for people with the CYP1A1 and 1B1. So if you do have to do that for a job, then you need to look at using gloves and avoiding caffeine, particularly if you're homozygous to the CYP1A1. All right, I'm going to hand you back to Cynthia now to talk a little bit about the 1B1s.
Okay, so this is CYP1B1, and the reason why, actually we have CYP1A1 and 1B1. The reason why this is an important slide is because, as I mentioned really early on, you have two phases in liver detox. Phase 1 converts an incoming molecule into an intermediary metabolite. Then that intermediary metabolite is conjugated and becomes water-soluble and neutralized. But along the way, these intermediary metabolites are made. So you'll see under 1A1, the 2-hydroxyestrone, and 1B1 is the 4-hydroxyestrone. Now, preferentially, you want the 2-hydroxyestrone. The 4-hydroxyestrone is considered pretty toxic, and if that builds up in the liver and escapes, or if it's neutralized and gets into the colon and goes back to 4-hydroxyestrone, it's very estrogen alpha receptor proliferative. And so that's where you start to see situations with fibroids, endometriosis, and even breast cancer. Now what you'll see here, if you follow the CYP1B1 pathway, eventually that 4-hydroxyestrone is converted through COMT through phase 2, and it becomes 4-methoxyestrone. So that's the 4-MeOE2. Once it gets to that point, it's neutral. Let me go, I want to skip ahead to the slide with the other drawing. Where is that? Can we skip down to the slide with the color pathways? One more, and then we can go back to this one. Let's go one more slide. Okay, this is a good slide. Okay, so this is a slide of the production of hormones, and you'll see in the top left is cholesterol. That's the basis for all of these hormones. If you follow these arrows, you'll see the interconversion between these molecules. Each one of these arrows is an enzyme, therefore, each one of these enzymes is coded for by our DNA. So if you go straight down into the blue box, that's where you start to have your cortisol. So if for example, cholesterol is converted to pregnenolone and then to progesterone, it has two choices. You can either go horizontally across and make its way into the estrogen box, or it can go down into the blue box, the adrenal box. And what you'll see there is this is when your substrates for making hormones is being pulled down. That's called a cortisol steal, and you'll see that under times of stress where your cortisol is high. And in some cases, things get so bad that for women, they'll stop cycling because all of their substrates are going to make flight or fight hormones and cortisol and those types of things. So let's just leave that for a moment and go cross horizontally to the yellow box. And you'll see three forms of estrogen, and I want to focus on the middle one, the estrone. There are three arrows. The longest arrow, the blue arrow, corresponds to cytochrome P450-1B1. The kind of reddish arrow is the 1A1, and then that shorter arrow is 3A4. But what I want to draw your attention to, those long arrows are phase 1, and you'll see if we just take that long blue arrow going to the right, you'll see estrone converts to 4-hydroxyestrone. That's your phase 1 portion. The 4-hydroxyestrone is your intermediary metabolite, and this is a bad guy. We don't want this. So the arrow going down, the pink arrow, which is the phase 2 arrow, converts the 4-hydroxyestrone to the 4-methoxyestrone, and now we're in safe territory. The 4-methoxyestrone can now be excreted. But if you look here, that arrow, the pink arrow going down, is actually COMT, catecholaminomethyltransferase. And so for those people, and we're going to talk about this next week, for those people who've got SNPs and COMT and CYP1B1, they're at a higher risk for estrogen dominance and problems that are associated with higher estrogen levels in general, not just the original estrogen coming into the liver, but these intermediary metabolites. And so I just wanted to point that out. But you can see that the CYP1A2 arrow that makes the 2-hydroxyestrone, which is the one we like, that's also broken down in phase 2 to 2-methoxyestrone through COMT. But that's not as dangerous as this 4-hydroxyestrone. So I just wanted to point that out. But you can see all these different enzymes and how they interact. Here's something interesting. Testosterone, which is in the gray box, can be converted to estrogens. And it's through an enzyme called aromatase. And aromatase lives in the belly. Aromatase is one of those enzymes that lives in fat cells. And so a lot of times people who, especially men, for example, who get that, kind of a belly, they'll start converting their testosterone to estrogens through aromatase. So they don't want that big belly. Okay, let's go to the slide before. This is the same picture. This is the yellow box broken down again. So you can see the estrogen E2, which is estradiol. Carolyn referred to it as E2. You can see the CYP1A1 going to the 2-hydroxyestrone, and then COMT to the protective, the one we like, the 2-methoxyestrone. And then you can, if you drop back here to the 4, again with the COMT, the 4-methoxyestrone. Now this diagram's a little bit misleading. This one is showing, well, no, I guess it's not. The 16-alpha hydroxyestrone is also something that has been shown to be estrogen alpha receptor proliferative. And in some of the testing that you'll see, they'll do a ratio between 16-alpha and 2-hydroxy, so that they'll do a ratio. And if the 16-alpha ratio is too high, then they say you're in kind of more dangerous territory. But really, the bad actor here is this 4-hydroxyestrone that's created through CYP1B1 upregulating, and then you have the COMT downregulating. And so that's something that you really want to look for. When you have your patients or clients and they're coming to you and they've got a lot of estrogen-related issues in their family tree. Maybe their mother had breast cancer or they're having issues. Really look at this, and there's things you can do to support COMT and speed up that phase 2 liver detox pathway, for example, magnesium. And there's things you can do to slow down the CYP1B1. For example, stay away from charbroiled meat, stay away from the things that Carolyn mentioned. So you want to slow down the 1B1 and you want to speed up the COMT to get your hormones into something that's in a more neutral state. If we go up a couple more slides to the CYP1B1 SNP slide, it talks about here, let's see, involved in the NADPH dependent electron transport pathway. Now the electron transport pathway is the pathway that kind of comes when the Krebs cycle is doing its thing in the mitochondria. NADP and FADH2 are output, and then they hop onto the electron transport chain, and we're going to talk about that in later classes. This is kind of an overview slide listing about what these CYPs break down. It mentions with the COMT downregulation, CYP1B1 SNPs plus COMT, specifically the H62H and the V158M could increase your risk of estrogen-related cancers. So keep that one in mind. That's a big one. Now, we haven't talked about this because we haven't got to COMT, but COMT is also a big player with respect to some excitatory neurotransmitters. Let's see. How about the next slides? Let's see. Here's a nice citation. It's not just the CYP connection with ovarian, breast, uterine cancer. There's also a risk to men, testicular and prostate cancer. So when you're looking at the variant report of men, you need to keep that in mind and ask some ask some detailed questions about their mother, for example, or their sisters, that type of thing, to see if they're possibly at risk. And then there's another article here about how CYPs are inducible by dioxins. And when we mean inducible, it means we're upregulating them, and we don't want that. Next slide. I think the next one's for you, Carolyn. We talked about that. Yeah, okay.
Okay, good. So thanks, Cynthia. So let's have a look at some of these SNP IDs and what the research is saying. So we know that the 1B1 is highly expressed in estrogen target tissues, so mammary, ovary, uterus, and specifically, as Cynthia said, it catalyzes the 4-hydroxylation of estradiol. And because it's this 4-hydroxy generates free radicals, which obviously causes cellular damage, that's why we've got it's so important for breast and endometrial cancer. And it no doubt changes the expression of estrogens. So the gene, if you look there, the C allele is the increased activity, and you'll see that as LEU, leucine, leucine. The clinical studies tell us that if you have a GG homozygous mutation, you are more likely to have lung cancer risk, prostate and endometrial cancer. The CC homozygous is more likely you see an increased risk of breast and prostate cancer due to that increased activity, as Cynthia just showed you on the chart. And as a general rule, the CG, which is the heterozygous, the research is telling us that there's a higher 2-hydroxy to 16 ratio. The 1B1 N453S, there's quite a bit of research on this. It's also known as the CYP1B number 4. It's the first step of estrogen metabolism, and so it's the GG allele in this one that's associated with decreased levels of 2-hydroxy and 16 in premenopausal, but an increased risk of this 4-hydroxy. And so many of you would already be doing estrogen metabolism reports for your patients, and certainly there's probably no one that comes in our door that has this SNP and or COMT that we wouldn't do the estrogen metabolism test. And certainly I would say 100, probably 99.9% have a dysregulation in their 2 to 16. Often you'll see a higher 4-hydroxy, but particularly, and it's been quite interesting to see that the 4-hydroxy in these people actually doesn't have to be off the chart for some of these women to be presenting with breast cancer. And obviously we know that COMT in combination with the 2 SNPs, you then have a 37% higher 2-hydroxy and a 26% higher 2-hydroxy and 16 alpha. And it's the GG allele that in the research is significantly associated with endometrial cancer. As far as the 48G, we know that one as a CYP1B1-2. There's been some studies looking at this in combination with the N453S, which is the one we just spoke about, with endometrial cancer. And if you had both of those, that you were certainly in a much higher risk of getting endometrial cancer, particularly the CC, but it's the GG that is protective for the endometrial cancer, but you're more likely to have higher 4-hydroxy, so an overall higher cancer risk. This study, you can't see it, it particularly well, but it looked at the association of the CYP1B1 with endometrial cancer risk in different ethnic groups. And they had a look at the R48G, the L432V, and the N453 and A119S in the CYP1B1 SNPs. And they found that there was an association with the R48G polymorphism with endometrial cancer. They also found that for the L432V, there was a significantly increased risk of endometrial cancer. So it's that combination too of the 48G, the 432V and the 453S that was definitely associated with the endometrial cancer. And this is really just looking at the polymorphisms in the 1B1 gene and how you are more likely to go towards that pro-carcinogen pathway and steroid hormones, and so definitely affecting mammary and lung cancer in humans. So the clinical pearls, Cynthia said a lot of these, we need to look at patients and their estrogen dominance. So cycle issues, fibrocystic breasts, fibrocystic ovaries, fluid retention, sleep disturbance, mood disturbance, constipation, heavy periods, PMS. And I'm sure most of you know it, but certainly from a clinical point of view, I would say if you're seeing homozygous CYP1B1, regardless of signs and symptoms, you need to be doing an estrogen metabolism test because, as I said, 99.99% they will have a disturbed 2 to 16 ratio. Also, really importantly, consider this in combination with COMT, and you'll often find the women that present with the fibroids and the fibrocystic breasts and the pre-PMS symptoms leading into their period, they often do have this combination. We've also got to consider it in relation to CYP17 and 19 because that does affect our breakdown of our estrogens as well. We need to avoid the xenobiotics. Remember, again, cofactor is heme, so check and address if there's any anemia. Always check estrogen metabolism, as I've said. Interestingly, activity of this is in tissue in the eye. So one of the things in the research, they say, look at CYP1B1. If there's any eye issues, then check for early onset glaucoma. Be cautious in caffeine consumption and avoid the estrogen mimicking foods, and definitely bisphenol A. Have a look and see if there's a homozygous COMP mutation. Particularly, we're looking at the H62H and the V158. Dietary advice. So increase activity. It obviously needs to be slowed down. Avoid the burnt or barbecued meats, as they're going to be broken down too fast and inefficiently, and potentially going into that pro-carcinogenic route. As per the CYP1A2, avoid estrogen mimicking substances and always assess. So this gives you an example of one of the studies that we do here. I know in the US you have some really great estrogen metabolism panels, so much more extensive than this. But you can see here's a classic example of someone who was homozygous CYP1B1. They weren't actually presenting with any symptoms to really complain of, yet look at that 2:16 ratio. This 16 was way off the chart. And for my liking, that 4-hydroxy is way too high. You can see it's a greater than the 2-hydroxy there. And I think we've really got to be getting that down. And I find one of the best ways to do that is calcium D-glucarate. And for the 16-hydroxy, I find that a combination of the indole-3 and the DIMS really good, as well as supporting liver function generally with things like Silybum or St Mary's Thistle. Okay, Cynthia's going to talk to you about the CYP2A6 SNPs.
Okay, so CYP2A6 is an enzyme obviously in the CYP2 family, and most of the SNPs in here are downregulations. Most of what you'll see on your report are downregulations. One thing that's interesting about this particular CYP is it's responsible for breaking down a number of coumarin-type alkaloid drugs and also aflatoxin. So that's something to keep in mind. So here it talks about the aflatoxin B1 metabolism, oxidation of nicotine, and metabolism of pharmaceutical carcinogens and coumarin-type alkaloids. But again, most of these SNPs here are downregulations. And so what that means is that if you've got activation, or if you've got, let's say, a xenobiotic that's being cleared in that pathway, it's going to clear slower. Now the next slide is the catalytic activity. And so what we've done is we've put together a compendium for each one of these SNPs, and if it's relevant, we have the catalytic activity and we have the cofactors. So you'll see the catalytic activity here. This needs oxygen and NADPH. So we're talking about some of the output from the Krebs cycle, and then this shows you, what the output is from that particular CYP2A6. And then, of course, the cofactor is heme, which is the iron molecule. Next slide. Here's an example of what the CYP2A6 cytochrome P450-2A6 enzyme metabolizes. So you'll see here a list of drugs. You'll see warfarins on there, and then also the substrates. So that means, for example, if you're exposed to this particular gasoline additive and your body has to clear it, it's going to go down the CYP2A6. There's the aflatoxin, valproic acid, which is a drug. But anyway, this is an example of a list of things that need to be processed through the liver via CYP2A6. Now, some of these have backup pathways. So in some cases, there'll be a number of CYPs that can help clear in phase 1. Same with phase 2. So for example, Carolyn mentioned dealing with those estrones, the 2-hydroxy-16 and the 4, and using calcium diglucarate, for one, and then the DIM. That's because the 3 pathways that clear estrogen in phase 2 are sulfation, glucuronidation, and methylation. So depending on what those intermediary metabolites are, you can support the phase 2 pathways with these different nutrients. Next slide is...
That one's mine.
Carolyn.
Okay, so if we now have a quick look at some of the 2A6, as Cynthia said, it's a down regulation or a slow metabolizer. And the things that this metabolizes is obviously the coumarins and nicotine and aflatoxin B1 and some pharmaceuticals. So we've got to be careful with our coumarins because we know that they're naturally occurring in some plants, and we just got to be careful also of the nicotine. So the 2A6 number 2 is a down regulation, slow metabolizer, and some of the research actually says there is no activity. So if you've got someone who is smoking and they're homozygous for this SNP, that's not great because there is no activity at all. And obviously if they're having a lot of coumarin type foods, then they're not going to be able to break those down either. The 2A6 number 3 is a down regulation and a slow metabolizer, but it's certainly not no activity. This one is just having a look at polymorphisms of the 2A6, and you can just see that some of them there, it says that there is just absent activity, particularly for those last 4. So the things we want to be doing if we're seeing the CYP2A6 is we've got to avoid inhibitors, because if it's a no activity or a down regulation, then we've got to be careful, with some of our pharmaceuticals, grapefruit juice, our methoxylin, which is you can see the trade names there, that's used for things like psoriasis and eczema, antifungals, and some of the antidepressants. So for the doctors there, important to have a look. Particularly, I look at all my patients' drugs and I compare it with their variant report, and if I see that a drug is metabolized through the 2A6 or whatever pathway and they're homozygous, I write a letter to their doctor and say, please could you swap, because this person is obviously not going to be able to metabolize, or you need to reduce the dose. So if you look at some of the things with the coumarins, they're foods that are high in coumarins you might want to consider looking at if someone is homozygous for this particular 2A6. And obviously avoid smoking, check iron again because it is a cofactor, avoid aflatoxins, and consider this gene in combination with the CYP2D6. That's where a lot of the research is coming up with this particular allele. Okay, let's look at the 2C9s quickly. I know we're running out of time, but let's see if we can get through this as quickly as possible. Cynthia.
Okay, the SNPs in 2C9 again are a down regulation, and the thing that's important about this particular SNP is that there's quite a few things that are processed through CYP2C9. One is diflucan, another is metronidazole, Flagyl, Luvox, and so if a person is taking, let's say, a round of diflucan for some sort of gut issue, and they've got this down regulation, they have to be careful. Because that particular drug will clear through that pathway. There's a list here of things that induce the enzyme. St. John's wort being one. But you can see this again. There's lists of all of these inducers and substrates in the compendium. Let's go to the next slide because I just noticed the time. We need to speed through it a little bit. Again, here's a list of the catalytic activities. There's 3 chemical reactions that take place for the phase 1 CYP2C9, and again the cofactor is heme. But the next slide. And then here's a list of some of the things that inhibit that particular pathway. And so if you're taking an inhibitor and it's clearing on that pathway, and that pathway is already downregulated because of SNPs, you can see where there could be some problems. So again, like Carolyn said, it's always good to look at a person's genetics, look at the medication they're taking, and just keep track. So that, for example, if they've got a pathway that's breaking down a drug they're taking and it's moving slowly, that particular drug will back up in their blood system. It won't clear fast enough, and so they would therefore need to maybe lower the dose below what the recommended dosage is. Again, there's that list of inhibitors. We can go to the next slide.
Okay, so I'll have a look at the research for the CYP2C9 number 2 is a downregulation or a slow metabolizer. It's a major role in xenobiotic and endogenous compounds, and there's obviously a lot of adverse drug reactions. Valproic acid is a really important one because there's a lot of people on valproic acid, and not only does it affect CYP2C9, but it affects our ammonia balance quite significantly, and it also has a major impact on methylation per se and our 5-methyl. So always look at valproic acid. I always worry about that one because it really does have such a major impact. The 2C9 number 3 is a downregulation or a slow metabolizer, and again the research predominantly around this one is in regards to xenobiotic and endogenous compounds. If we look at depending on the SNP, if your patient is showing signs of not being able to metabolize certain drugs, then we really need to look at dosage, particularly if something is metabolized through that. And as Cynthia said, most of these are down regulations, which means the drug isn't going to be cleared. So for the doctors out there, we need to be looking at dosage levels and perhaps coming back on the dosage for these people. Limit xenobiotics, herbicides and insecticides. And 25%, as Sterling said, of all clinical drugs use this pathway for metabolism. So we really have to keep this one in mind when we're prescribing drugs if someone has a homozygous mutation. And encourage inducers and avoid inhibitors. So natural inhibitors, important. A lot of practitioners will be prescribing quercetin and flavones. So if someone, we don't want to be inhibiting something that's already pretty well slowed down. A good inducer, although weak, is St. John's wort or hypericum. So that's probably something that we could consider to help move it along. And as I said, make sure we're looking at dosages. And these are the list of some of the very strong inducers and our moderate inducers, and that's fully in the compendium. Okay, CYP2C19 SNP, Cynthia.
Okay. Again, CYP2C19 is another cytochrome P450 pathway. Some of the SNPs here cause a kind of a rapid metabolism. So, and Carolyn will speak to that. Where, for example, if you're taking a particular drug that's cleared in this pathway, let's say like an SSRI, it's going to be processed pretty quickly if you've got certain SNPs here. So that again needs to be kept in mind. Same with proton pump inhibitors; those are really big in the U.S. now because they're now being sold, over the counter, and lots of people take those for heartburn. And people that have an upregulation in this enzyme, they might not be very effective because they're going to be clearing them pretty quickly. Diazepam is on there. So again, look at the list to see what's being cleared in this particular pathway. Plavix is here. And so it's really important. I can't stress enough. It's really important with your clients to sit down and look at their CYPs and look at what drugs they're taking, and even some of the supplements like St. John's wort, because those will affect these pathways as well. Let's go to the next slide. Again, the catalytic activity and the cofactor. Let's go to the next slide. Can we go on to the next slide? Yeah. Strongly inhibited. This pathway is strongly inhibited, meaning that it's slowed down by these particular, let's say, this particular antidepressant or SSRI. It's induced, meaning that it speeds up with some of these other drugs down here. So, for example, prednisone will increase the speed of that particular CYP, 2C19, and things like aspirin. Next slide. I feel like I have to hurry now because we're running out of time. It's predominantly expressed in the liver, but to a lesser extent in the small intestine, which is what a lot of these CYPs have in common. There's the list here of what's metabolized: antidepressants, antiplatelets, and proton pump inhibitors. What induces it? There's an interesting note here. Women that are taking steroid oral contraceptives like birth control pills have reduced CYP2C19 activity, so it slows that down. SSRIs also slow it down. Let's go to the next slide.
Okay, so what the research is telling us is that RS1224850 is an ultra rapid metabolizer. So it's going to break down drugs too quickly, especially our proton pump inhibitors. And the 2C19 number 2 produces a reduced activity. So you can see that the different alleles can actually work in complete opposition. So really, again, the clinical pearls in this is to check the iron, because it's, again, another cofactor. Avoid inhibitors in reduced activity and use natural inhibitors in fast metabolizers. So, for example, anthocyanins in berries are moderate inhibitors. So we need to consider things like that when someone has already got inhibition of this enzyme. So if we look at Cynthia's CYP2D6 SNPs.
Okay, so this is, again, highlights. It's primarily expressed in the liver and central nervous system. This is a big one for metabolizing pharmaceutical drugs, and there's a nice list here, things that are metabolized. Beta blockers, that's important to look at. Prozac is an inhibitor of this enzyme, meaning that it will slow the enzyme down. And if we, I don't know if it's on the next slide, but if we keep going, you'll see that codeine is involved and a whole bunch of other commonly used medications. Here's the catalytic activity, and of course the cofactor heme. Next slide. This is a table that's in Wikipedia, and what this shows you is the research that's been done on this particular enzyme. Most of it's been done by the pharmaceutical companies, because they have to gauge whether or not a drug is going to affect a particular pathway and what their risk is when they're telling people this is the dose you're supposed to take. But these CYPs, you can see they vary a lot. So for example, CYP2D6*2 is increased activity, and whereas CYP2D6*10 is decreased activity. And Carolyn will talk about the different alleles. One of the other things that this enzyme metabolizes are herbicides and insecticides. So you want to take a look to make sure that somebody's not having, decreased activity, or that they're not doing something to downregulate that enzyme. Say, for example, if they live on a farm. Next slide. This is some research that's cited, this is actually out of Wikipedia, and you can see that they've got a list, and this is just a partial list. The list is very extensive of the substrates, the things that are processed in phase 1 liver detox, things that inhibit it, and then things that induce it. And what you can see, this is, like I said, a very long list. The inducers are not are what you see, but the substrates and the inhibitors go on for probably 4 times this amount of pharmaceuticals.
Okay, so if we look at some of these, this is, I've got to say, probably the hardest section to really get good clinical evidence on, and it took months to try and find this, because it's just, I think part of the thing with the CYP2D6 is there, if you can see the different alleles there, the 1135840, it's the GG that is considered normal. It's the CC that's the fast activity. And so you've got to be quite vigilant when taking codeine, because there will be a potential toxicity. The T100C, the TT is non-functioning or partially functioning. So really you can say almost no activity. And interestingly, it's the T allele that we see in Asian populations. The 16947, it's the AA allele that causes an upregulation, so a fast activity. But it really was very difficult to find any fantastic trials. I think that's probably why a lot of it's published on Wikipedia, because there are a few studies there I've given you the links to, but it's quite difficult to find anything of any substance with the 2D6. And again, what I look at with drugs with patients is, if you consider that something is a fast activity, so that's CC allele, then you've just got to be, you've got to look at dosage. Is it enough or is it not enough? If it's not functioning, then they're not going to be able to process their pharmaceutical drugs pretty well at all. Or if they do, it's very, very reduced. So you've really got to look at your dosages. So again, cofactor is heme, so we need to check our iron levels. It also clears, as Cynthia said, insecticides and herbicides. So if you've got patients with this, caution them about using some of these in their home. And 25% of all drugs are used, are metabolized through this pathway. So we've really got to look at that with our patients too. An inhibitor will cause a decreased clearance of the drug, so we'll get high plasma levels, and a fast metabolizer will metabolize it too quickly and potentially put pressure on our phase 2. So we'll have a quick look at the CYP2E, Cynthia.
Yeah, this is an interesting enzyme. CYP2E1 is located in the dopamine-containing neurons. It also plays a role. There's a constellation of SNPs that play a role in the development of Parkinson's disease, and this is one of them. And it doesn't seem logical, but it is. This, along with some of the neurotransmitter SNPs. Having SNPs here can increase reactive oxygen species in the presence of these chemicals that cause the pathway to slow down. Coffee and smoking again exacerbates. Alcohol, being diabetic, and being hungry in a starvation state induces the gene, so it upregulates it. A couple other things that are interesting about this is one of the enzymes, one of the phase 1 enzymes that clears acetaminophen. So for those babies that are getting their vaccines and then they're giving their child acetaminophen, we call it baby Tylenol here, and they have glutathione SNPs, you have to really be careful, because you're downregulating phase 1, and if there's glutathione SNPs, because that's the phase 2 portion of acetaminophen clearing, that could be a problem for those children. Let's go to the next slide. It's inhibited by antifungal drugs, and there's an interaction with ciprofloxacin. Cipro and all these fluoroquinolone antibiotics. We're going to talk about that later, but they're very reactive with these phase 1, phase 2 liver detox pathways, as well as mitochondrial DNA. So we'll talk about that at a later time. Let's go to the next slide. Again, the catalytic activity, you can see the NADPH and the oxygen are part of it, also iron. So it's kind of a double thing here, right? You need the heme and you need the oxygen. Let's go to the next slide. That's an interesting slide. I mean, that shows some of the pathways and how caffeine and the different drugs. You can blow that up and take a look at it, but it just shows you the different enzymes. So, for example, caffeine is acted on by CYP1A2, 3A4, and 2C something. That's too small for me to see. So we can go to the next slide.
Okay, so when we're looking at the research, like many of these, we're looking at combinations. So CYP studies show that really there's a combination of 1B1, 2D6, 2E1, and 3A4 are the ones that they look at a lot in the research, particularly in association with non-small cell lung cancer in smokers. The 1B G allele is induced by alcohol, coffee, and smoking. No real definitive up or down regulation with this, but it works with other genes in regulating. So if you can look at someone's diet and lifestyle, you can work out with this one whether or not they are, if they're a coffee drinker and they drink a lot of alcohol and smoking, you know that they're going to be inducing this gene. The CC is considered to be the wild type. With the 2E1 number 4, it's the AA is like the above. It works with other CYPs to detoxify our carcinogens. So no real research in terms of definitively up or down, but certainly we know induction or what causes a down regulation of this particular gene. Our clinical pearls, we do need, like the 1A ones, consider our glutathione genes, as Cynthia said, so our GSTM1, GSTT1 and GSTP1. Avoid xenobiotics, avoid drugs that inhibit this enzyme, and the book has got more information on that, and avoid our strong inducers like ethanol and tobacco. 3A4 is next.
CYP3A4, this is a big one. Now, you don't see a lot of SNPs, at least I don't when I look at these variant reports. I see a lot more in the CYP1 family and the 2 family. The 3A4 is a very big clearer of pharmaceutical drugs. And again, there's a list here. It metabolizes xenobiotics. It's been related, the expression has been related to estrogen-related cancers, and we actually talked about that with that estrogen slide because it's part of estrogen breakdown. And then there's a note here about caffeine and how it can elevate estrogen levels up to 70% of CYPs are present because, again, this is another pathway to clear caffeine. So let's go to the next slide. The list of inducers, CYP3A4 has a lot of information about substrates, inducers, and inhibitors. And in the compendium, I probably got 6 pages of them. But one of the ones that you see a lot, or when somebody takes a medication, they're cautioned against having grapefruit. That's because there's a particular chemical in the grapefruit that will inhibit the function of CYP3A4, and if the drug that they're taking has to clear on that pathway, they don't want to be drinking grapefruit juice and slow that pathway down because, again, it will change the plasma concentration levels. Let's go on to the next slide.
Okay, so when we look at the research, a lot of it really is around the oxidation of testosterone and estrogen, particularly our 4-hydroxy and 16-alpha hydroxylation. The CYP, as far as androgen metabolism is concerned, we need to consider this in association with prostate cancer, and because it will deactivate our toxic testosterone. So if we inhibit it, it makes sense that it would result in increased bioavailability of testosterone. The 3A4 star 1B, the G allele, is more common among African American men than white. So that's really important for those practitioners in the US, in that in white men it was associated with a 7% versus 60% in African American men. And those with the GG allele were more likely to have an aggressive prostate cancer. So the research seems to suggest that this is quite a significant downregulation. The CYP 3A4 star 3, although there was a significantly, research showed us that there was a decreased risk of breast cancer on its own, but when it's actually combined with the CYP1B1, and it's that RS1056836, the V432L, there was a significantly increased risk of developing breast cancer if the person was exposed to radiation. So that's a really important note, because how many people or women are we saying after the age of 50 you need to get a X-ray, a breast X-ray every single year? Well, these are the people that in the research that the studies are saying they should not be. They should be using things like thermal imaging instead of having a breast X-ray, because they were more likely to develop breast cancer if they were exposed to even low levels of radiation in breast X-rays. So I thought that was a really interesting note there. So it was that combination of the 3A4 and the CYP1B1. So the clinical pearls, we need to consider the inducers. So DIM inducers, St. John's wort, valerian and ginkgo biloba, and inhibitors, horse chestnut, echinacea, sage, ginkgo and milk thistle. We need to check our steroid hormone levels, avoid our xenobiotics, caution patients, as we said, with that concurrent CYP1B1, and really consider whether breast X-rays every year are warranted, and encourage men to get regular prostate checks and support estrogen and testosterone metabolism in both men and women. CYP3A5, Cynthia.
Okay, so CYP3A5 is expressed in quite a few places, including the prostate, the liver, the small intestine, and the large intestine. It's involved with breakdown of testosterone, progesterone, and androstenedione. It's also the pathway that's used to clear the drug that prevents organ rejection. It's the sister to CYP3A4. Now, most SNPs in CYP3A5 cause a downregulation of this enzyme. And again, like CYP3A4, there's an extensive list of substrates, inhibitors, and inducers. So again, take a look at that. I'm trying to see if I've got any interesting little tidbits here. Really, the only big takeaway here is that the star 1 version is the only version that really does a great job in clearing. The other SNPs will slow down that pathway. Let's go to the next couple slides. Let's kind of zip through the next couple of slides. Okay, again, that's the catalytic activity and the cofactor. Let's go to the next slide, please.
So that's me. So In terms of the 3A5 number 2, it was really a non-functioning allele. And the 3A5 star 3, it's the G allele that shows low activity. And the only real research we could find, interestingly, with the non-functioning allele, that A allele, research showed that there was a 64% increased risk of developing acute lymphoblastic leukemia in childhood when that gene was expressing. All right, so let's get on to our last section, which is our hemochromatosis proteins.
Yeah, HFE, this is a big deal for people. I mean, we always talk about mercury and some of these other heavy metals, but when your iron levels go high and your percent saturation of that iron, and ferritin and things like that goes high, that's a problem, because that level of circulating iron is just as dangerous as circulating mercury to the organs. So when people have SNPs here, you really have to take a good look at not only their HFE status, but also G6PD, like Sterling mentioned, SOD2, and RAB6B, and look at a full iron panel. As we look at some of these SNPs, one of the questions a lot of people have when they get the report is they're like, okay, there's 3 reds here and 2 yellows, and these are green, and what does all this mean? With the HFE SNP, it's pretty clear. If you've got even just 2 heterozygous, 2 yellow, or 3 yellow, or 1 red, that needs to be monitored. That whole iron, ferritin, TIBC, percent sat, that should be monitored on a regular basis. And caution needs to be used with taking vitamin C if somebody has SNPs here. Let me see if there's anything in here that's, yeah, we've covered that. Sterling talked about that. Let's go to the next slide. HFE protein interacts with other proteins to detect the amount of iron. Yeah, so this is interesting. The CYP, the HFE C282Y gene, there's been some research to indicate that it also may be associated with Alzheimer's. And again, circulating iron, free iron is not what we want. We want that iron tiger in its cage. Next slide. This particular, the BMP2, is associated with hemochromatosis as well, and increased iron. So again, that's another one to look at. I recently had a guy whose ferritin level suddenly went up, and it was before we got his Verin report back, and his father had a history of a lot of issues and died at 54. And it turned out it was iron related. And so in his case, we're looking very carefully at all of these SNPs, because we have to figure out, why his iron is so high. He definitely has HFE, and he's also got the some of these other associated SNPs. So we're monitoring him very carefully. How are we doing on time? I think let's go on. Let's move to the next slide.
Yep, so the only thing I wanted to say about that is it's interesting with this hepcidin. There is what's called a hepcidin model of iron homeostasis, and it really depends on the plasma level of hepcidin. So the theory is that when iron levels are high, the synthesis of hepcidin increases, and the release of iron from enterocytes and macrophages is diminished. But when iron stores drop, the synthesis of hepcidin actually goes down, and so these cells will release more iron. So if we have a look at how that plays out, you can see here that increased hepcidin synthesis mediates iron, and in individuals who don't have any mutations, the hepatocyte is thought to really react to either an increase in iron saturation of transferrin or to increased iron stores in hepatocytes themselves. because it induces the synthesis of hepcidin. So we're seeing that the physiological response to iron overload under normal circumstances would be the hepcidin-mediated shutdown of iron absorption and recycling through the macrophages and storage with the hepatocyte. But we can also see that the synthesis and release of hepcidin is really controlled by interleukin-6, which is quite interesting because it's then going to be overexpressed in response to inflammation. So if we consider that any cytokine mediation or mediated hepcidin induction, which could be caused by inflammation or infection, is now thought to be responsible for anemia of chronic disease. And if we have a look at the other hand, if we've got a downregulation of hepcidin, that's going to result in an increased iron release. And the key SNPs here you can see in the HFEs are the C282Y in combination with the H63D. I rarely see the H63D causing major issues on its own, but certainly in combination we need to be considering that there could well be an iron overload. And so I think the clinical pearls here is that we would obviously need to have a look at any signs and symptoms of iron in our blood work. Is there an increased saturation percentage? Really, we say it's over 50%, but we can get over 50% just with having low 5-methyl. So we don't always have to assume that it is hemochromatosis, but over 50% we really should check. Increased ferritin levels, so over 250. There may be joint pain, fatigue, weakness, lethargy. I'm sure you all know the signs and symptoms. So the key strategies obviously are regular phlebotomy and never give IV vitamin C. Key strategies to support obviously calcium, because calcium will bind with iron. Higher oxalate diet, well, as Sterling said, that's not necessarily a great thing, but it will bind with iron, and consuming tea and coffee with meals as tannins will bind to the iron from the meal. And that's one of the issues we have with our elderly, because they tend to have their cup of tea with their meals and will have a reduced iron level. So the key SNPs are really to look at in combinations here are the SOD2A16V, because it is iron binding, and the HFE, because they can cause a 10-fold increase in heart disease if we have that combination. As Cynthia said, G6PD, and as Sterling said, the RAB6B in combination is important to look at. So last one, PON1, we can flick through this pretty quickly, Sterling, Cynthia.
Yeah, the significance of this is an enzyme that's really important in breaking down some of the insecticides. And so when you see a SNP in PON1, a lot of those people typically have more of a problem, breaking down the insecticides. So they have to be really vigilant about trying to eat organically, stay away from grains that are genetically modified so that they can be sprayed liberally. But that's really the big takeaway with PON1. Yep. Sterling mentioned that there's an association with PON1 and vascular disease. But again, the big takeaway for PON1 is just understand a SNP there. And I've only seen one homozygous SNP in all the reports I've looked at. I've seen quite a few heterozygous, but a SNP in PON1 means that particular person has a really difficult time clearing insecticides.
And specifically, that is the organophosphates. So you can see there the PON1 Q192R C allele is the one that metabolizes these organophosphates in the insecticides. And there is a risk factor for increased oxidative stress. Interestingly, that both polymorphisms were associated with bipolar as well. There's just a study on the prenatal exposure to organophosphates for those that had the PON1 gene and having an adverse effect on mental development. Particularly, the effects weren't seen until about 12 months of age. So that's a really important one to also women that have mutations in this in preconception to ensure that they are avoiding organophosphates. And really, there's just a list of some of the typical organophosphates that we see. And I've given you a link there so you can look that up a bit more. Signs and symptoms of organophosphate toxicity, there are some of them. And interesting, the convulsions is a big one. So just something to consider if some of your patients present with this. And here we've put together some of the questions that you might want to ask your patients. Are they aware of the Dirty Dozen list? It's good for them to have a look at that. I've given you the website there. Are they living in areas that are growing these foods, particularly peaches, apples, grapes, green beans and pears? And if they can't afford to buy organic, are they washing their fruit and vegetables? And it's interesting, I listened to an environmental masterclass on this, and one of the presenters was suggesting that I guess it's better than nothing, but really it's not going to get rid of those organophosphates. And as I said, we really need to be looking at our pregnant women or our preconception. And cofactor for this is calcium, so make sure we are checking calcium levels because it binds 2 calcium ions per subunit. And I think we'll just skip through SOD 3 because there's not really a lot there that we need to say that's particularly, other than obviously copper and zinc is really important here. And I find that most SOD 3 people, patients will have issues with copper and zinc, and usually it's too high copper, not enough zinc. All right, so Sterling, we need to hear from you. We haven't heard from you for a while, and I guess you've got some good insight in terms of how we should combine a lot of these with the CYP2s. Have you got anything to say in relation to that? I think Sterling's on mute.
Oh, I'm sorry, I was muted. Be careful what you ingest and eat, and be vigilant. That's the main thing. We know, a lot of us are saying now, something more or less like your genes are the hand you have been dealt, and how you play the hand is going to result in an outcome. This is a great place to look for people when you get someone chronically ill and they just cannot be fixed. These genes, you can look at them and say, hey, where can I test? Should I test estrogen levels? This person's loaded down with many CYP genes, and yeah, you can go and test. And then when you see them in combinations with things, especially comp V158 MNH62H, very important there. Yeah, chronically ill person, you should check their hormones and write a list of their diet, write a list of their medications, look at all those CYPs and the meds they've been on, even, for instance, cinnamon supplement for some of these SNPs and CYP because of the coumarin. Very, very important. You can save a life. You can prevent cancer. I feel this is very important.
Okay, Suzanne, I'm sure we have some questions.
Yeah, we do actually. Thank you very much for some really great presentations there from everybody, but we do have some questions, so that's good. Now, the first thing that I'd like to ask you is that there's been a number of times that you've referred to a compendium. Is that something that you're going to be sending people, or is that something that they can pick up somewhere?
I can answer that. Am I on mute?
No, you're fine. You.
Okay, yes. The SNP Compendium 1 has been in the works all summer, and it should be out. It's a book. It's an 8.5 by 11 book, so it's almost like a big workbook. and it has all of this information in it. It covers phase 1, phase 2 liver detox, including all the methylation, alcohol, histamine, neurotransmitters, and mitochondrial SNPs. There'll be a compendium too at some point that will include the GI and the different immune and autoimmune SNPs, but that one will probably be, I don't know, 500 pages. This current one, the SNP Compendium 1, which is comprised of overviews, some of the called research, pathway drawings, and then what we call our 2 cents. This one's about 330 pages, but like I said, the next one will be probably closer to 500. But what it is it's a reference guide, and you have everything in one place. You have the drawings, you have the research, you have these lists we were talking about with substrates, and then you have clinical pearls. So that should be out probably next week.
Okay, great. Thank you, Cynthia. Also, I've noticed that you've got the presentation that we've been referring to throughout today. So that's actually provided for you in the handouts. So all you have to do is click on the file itself and download that. So I have another question here from David. Is 1B1 always an up regulation? And I think that one's to Cynthia.
That's a hard one because you can't really find research that says it's a definitive up or down regulation. Really the way I try to explain it to people is if there's SNPs in 1B1, then you're more susceptible to upregulating that enzyme by things we discussed, charbroiled meats, PAHs, different chemicals, and we really want to try to keep our CYPs, our phase 1 speed, and our phase 2 speed matched, because we get into trouble when one's down and one's up.
Okay, thank you. I hope that answers the question. So the next question I've got is from Thomas. With HFE, the vitamin C caution is because of increased iron absorption?
Yes, that's correct.
Okay. And I have another one here. I have patients who have told me that mailing 23andMe testing is expensive from Australia. Do you have a way around that?
Well, it's actually not. It's only $99. It's $99 US, which is, are you talking about mailing it back? Is that what you said?
Thomas, do you mean by mailing it back?
Because it's $99 US to do the saliva test. They send you a prepaid post bag back. So all you have to do when it arrives is collect your saliva and call the courier company, and they will automatically send it back. So that includes, you do pay a courier price on top, but it includes your ability to send it straight back to them.
Okay. Just going back to the compendium, I wasn't sure if you said there, Cynthia, was it available for purchase next week?
Yes.
Yep. Okay.
And we'll put up the links to the website. It'll be coming out in a soft cover, and like I said, an 8.5 by 10, or sorry, 8.5 by 11 soft cover book. And we picked this size because when you open it, it stays open. We wanted a big enough book so that it can lay flat. So we have the book, and then we're also going to have it in a downlink version for your computer. But having worked with both, I can tell you having the book is really nice to have sitting open next to you and not scrolling up and down through an electronic version.
Okay, excellent. And just as another sideline there, Cynthia, people that are attending this class, do they get a discount?
We could do that. I have to figure out how to do that, maybe with some sort of coupon code. But let me talk to Carolyn and Sterling about that. The way it worked out is by the time we print it and ship it and take care of the back end people, the profits aren't really that great. But yeah, let's see what we can do to get a discount on it.
Okay, excellent. I have another question here for you. Can you please say more on the connection with iron and vitamin C? Would vitamin C supplements be okay, a small amount, or should you only get vitamin C from the diet? That's from Donna.
Can I answer that one?
Yep.
Okay. Artificial C seems to be much worse. looking in studies than natural sources. For example, when you have HFE in combination with G6PD, artificial C, they always advise never to take with G6PD because it'll just make it much worse with HFE. It'll actually make your red blood cells explode and oxidatively damage all your reduced glutathione. So they say more natural sources, but again, separating your C-rich foods from your iron foods are the best way to go. Do not eat vitamin C and iron foods together because you do have to have some little source of it for your immune system. But that is very important to know. The artificial ascorbic acid is really not a good deal for anybody with G6PD and HFE SNPs.
Okay, thank you, Sterling. And Donna's asking again, when the 2:16 ratio is out of balance, in other words, the 16 is too high, would grapefruit be good to eat? Who can take that one?
Cynthia, do you want to take that?
What was the question? If somebody has the 16 alpha to 2 ratio, would grapefruit be good to eat?
Yes. If the 16 is too high, would the grapefruit be good to eat?
It's not as impactful to that pathway as grapefruit is more impactful to the 3A4 pathway and the 2D6 pathway. So I think a little bit of grapefruit would be fine. Don't have lots of grapefruit juice and things like that because you really don't want to be messing up your CYP pathways. But for that combination, I don't think it's such a big deal.
And I think if that's a question in relation to would it help, well, no, it's not going to help either enough to change that ratio of 2 to 16.
Okay. So just a couple more questions and then we'll need to close this webinar off. So of all the CYP SNPs, which ones do you see the most? So that could be Carolyn or Cynthia, please.
Well, I definitely see CYP1B1 expressing a lot, and often I will see homozygous for all of them. That's not uncommon. And I see probably CYP2D6 as the second one that I would see the most. Cynthia might see something else, but I certainly see those two expressing.
I can add, because I have the variant report there and I have thousands and thousands of people asking me to take a look. I agree with Carolyn, the 1B1 and the 2D6, you see them quite a bit.
Yeah, same here. I very rarely see a 3A4, and then I see assorted, 2C19s, that type of thing, some 1A1s, but really, I really hone in on the 1B1s.
Okay, excellent. We've just, Donna's just saying thank you. That was the answer to her question. Wonderful class. So she's really enjoyed it. Thank you, Donna, for that. So listen, we have run over a little bit, but just to let everybody know, the future classes, we are going to set the time so that it's a 2-hour class. You did get the notification that it was a 1-hour class, but we will be changing that. You will be notified it's going to be a 2-hour class. And so the next class, the class is going to be on each week at 7:30 p.m. For the US, and for Australia 11:30. That said, the clocks are changing in the US, so we'll keep you informed of that anyway. So the next one is on the 13th of October for the US at 7:30. That's liver detox phase 2. That's the 14th of October at 11:30 a.m. for you guys in Australia. And then the next one after that is the 15th of October, 7:30 p.m. for the US. That's yeast, alcohol, and Alzheimer's. And that was the 16th of October, 11:30 a.m. for Australia. Okay, so the first week of November, the times for us will change in Australia. Okay, so I really want to just say to each and every one of you that have come along to this lesson today, thank you very much for showing up. I hope that you found that the information has been really useful for you. If you do have any questions prior to any of the webinars that we're running, please feel free to email us on info@mthfrsupport.com.au. That's info@mthfrsupport.com.au. So please forward your questions prior to the webinar as well, and we'll get through as many as we can. And then finally, I just want to say a big thank you to Cynthia Smith, Sterling Hill, and Carolyn Ladowski. Is there anything that any of you guys would like to add before we close this webinar off today?
No, other than it's really quite exciting to do this and present this information, because you know the combined experience is really what makes the difference here, and being able to give you clinical insights and tips on how you're going to look at it. And by the end of this class, you'll be able to really get a good feel for what you need to be looking out for, key SNPs in each category. And I think that's what's really overwhelming for a lot of people, because there's a lot of information here. And so if you can pick one of these up and know what sort of questions you need to be asking your patients and what sort of things you need to be considering, I think that's really invaluable. And what Cynthia and I are seeing from a clinical point of view is this makes a huge difference, particularly for your really sick patients. So it is exciting, and we have to thank Sterling for all her great work in putting this fantastic variant report together.
I couldn't have did it without you guys, though. There's many a night Cynthia and Carolyn has gotten with me and said we need to look at this, look at the SNP better, sending me studies. I think it's all been a team effort.
Great. All right.
Well, I've thoroughly enjoyed the webinar, and I'm sure that everybody else has and got a lot out of it. So if there's nothing else, I'd like to just close off the webinar by saying thank you very much. Make sure that you've put it in your diary, that you've got these lessons coming up over the next couple of months. And we'll see you on the next webinar next week. So thank you very much, everybody. Bye-bye.